Hi, today we want to learn mapping the seagrass using the Landsat satellite and Google Earth Engine. Seagrasses are submerged aquatic plants that play a crucial role in the coastal ecosystem, and they support the biodiversity, stabilize the sediment, and sequester the carbon. Monitoring the seagrass health and extent is essential for the marine conservation and climate studies, and seagrasses like the terrestrial vegetation reflect the near infrared light and absorb the red light for photosynthesis, and the normalized different vegetation index or NDVI used to property to detect the vegetative presence and including the submerged vegetation in shallow coastal waters where seagrass grows. However, care must be taken to mask land and distinguish the seagrass from the terrestrial vegetation, often by applying the threshold to the NDVI and utilize the high resolution satellite imagery. Application of this in a marine habitat mapping, blue carbon monitoring, coastal ecosystem health assessment, and baseline data for marine protected areas. In the coding part, we zoom at the Tasmania area with creating the bounding box. If you don't know how to create the bounding box, you can watch the video from all channels. And if we zoom here, we our interested area is the Northern Tasmania's areas, and after this we can load the Landsat 9 image with from the image collection, and we load this from a Landsat. You can watch video about Landsat True Color from our channel, and we use it the band 2 and band 5 of the surface reflecting response, blue band 2, band 5, blue, green, red, and near infrared. And data is scaled to the reflectance using the Landsat 9 scaling factor based on user guides, and cloud filtering ensure the only very clear seasons are included. We use it the 2% here, and after this step we can calculate the NDVI with a variable with NDVI L9.map function. We define the NDVI normalized difference to band 5 and band 2, which we name of NDVI, and this index help identify photosynthetically active vegetation, including the submerged aquatic vegetation. And step 4 is creating the composite image. This produces the mean NDVI and RGB images over the selected data range to reduce the cloud noise and highlight the persistence features. And after this, we need to mask the land areas. We use it this land usually shows a high NDVI greater than 0.3, and we use it this threshold to differentiate the land vegetation from the water seagrass. Step 6 is mask the seagrass areas. We define it the where seagrass mask. We assume seagrass is shallow clear water, shows a low positive NDVI 0 to 0.3, and these filters are that are not only but have some vegetation signals. And after this, we need to add a resolution step like this, and we added the true color 1, 4, 3, and 2, and we added the seagrass mask from the update mask of a seagrass with a palette of a green, and we name it the layer detected seagrass. And if we run this code, we have a two color here, the two color composite of this, and detect the seagrass areas like this. And you can export the GeoTIFF of this or time series analysis of this. For time series analysis, you can watch video the soil moisture. In end of soil moisture video, we generated the time series. And for exporting the geotiff, you can watch the video of a berry soil. We generated the base geotiff of a berry soil, and you can use the same here. And if you're interested in the seagrass mapping and monitoring, you can watch the video about the Sentinel-2 seagrass mapping videos. Thank you for your watching. Please like and subscribe our channels.